grade 10s, and welcome to some more work with angles and their relations. So angle relations, it's what we started last lesson, is looking at the fact that, if you recall, and hopefully you did the assignment so you do easily recall, angle relations are based on adjacent angles. When multiple angles share a ray. So if I have a 90-degree angle, but I put another ray in there. Well, if I label it, I have two different angles making up one bigger angle. Here we have angle ABG, and we have angle GBW, but those two angles together. So if I took angle A to B to G and take that value and I measured it and included it with angle GBW, which is that size, well, then the two of them together, ABG plus the GBW, will total 90 degrees because they total angle ABW together. ABW is the big angle. And what do we have? When multiple adjacent angles equal 90 degrees, we have a complementary situation. These angles are complementary because they total 90 degrees. We can do the exact same idea by starting with a straight line or a straight angle. I could say that this is angle WXY. Well, angle WXY we know is 180 degrees, but if I added in a different ray, call it J, well, I now have, again, adjacent angles, two angles connected by the common ray. We have angle WXJ, but we also have angle JXY now. JXY. And together, those two angles, when I combine the size of each, create one big angle. So together, they total 180 degrees, and that makes them supplementary angles. And the last little bit we talked about last lesson was the idea that anytime you have two intersecting lines, lines being straight, we create four angles. But as soon as you have two straight lines that intersect, well, opposite angles, angle 1, that size, is exactly the same as angle 3. So angle 1 equals angle 3, and then we also have, opposite each other in this case, angle 4 is opposite angle 2, and angle 4 equals angle 2, because both of these create opposite angle situations. So hopefully you did the practice with that. And now we're going to look at a unique situation. So what you have to do is you need to pull up the angles, symbols, and transversals sheet that is probably in the worksheet section. It's not in the notes pack. So if you haven't done so, pause the video, print this off, or pull it up, because we're going to work back and forth with it. Angles, symbols, transversals, but we're going to do this, and algebra. We're going to do a little algebra with these relations. So what's important is we can have unknown parts tied in with angles that we've just talked about. And the best thing to do is to just look at the first example, where here we want to solve for x. We want to know what's the size of the x in this angle 4x plus 20. Well, in order to figure out what an unknown is, I need some kind of a relationship because I need to create an equation. But before I can create an equation, I need the relationship, and I am so hoping after the last lesson and the little bit of review I did a minute and a half ago, we see two lines intersecting, and we therefore know angles opposite or across from each other are the same. So as opposites, we know that both those angles have to be 60. If this angle is 60, the one opposite also has to be 60. So we can create the equation. This 4x plus 20 has to equal the angle opposite it, which is 60 degrees. So there's an equation with the unknown. A little bit of algebra, solving an unknown by identifying the relation and putting it into an equation. And now we can solve. A little bit of algebra. Subtract 20 from both sides. We're left with 4x equal to 40. Divide both sides by 4. So x equals 10. Now, here's where you have to be careful, because I've had students in the past say, well, we just said that this angle has to be 60 degrees, but you're telling me it's 10. I'm not telling you it's 10. I'm telling you x is 10. So if we do a quick check and I plug that x value of 10 into this, 4 times 10 plus 20, 4 times 10 is 40, plus 20, there's the 60 degree angle, which it should be because it's opposite 60 degrees. So this little concept is just about thinking and bringing two concepts together. Thinking about the angle relations and then having to solve for an unknown. So here's the example underneath. It wants to know how big is x. We'll take a quick look. What do you hopefully notice about this particular diagram? I'm really hoping that you notice that there's that little box in the corner, because that little box tells us we have a 90-degree angle. So angle ABC is 90 degrees because the box tells us that. What do we have? Here we have a complementary situation. Complementary angles. Because angle ABD along with angle DBC, two angles that make that 90 degrees, so they're complementary. So how can I create the equation? Well, we know that this first angle, ABD, along with the second angle, DBC, has to be 90 degrees. So the angle that's 4x plus the angle that's identified as 2x has to be 90 degrees when they're combined. First angle plus the second angle totals 90 because they're complementary. So now we can solve the equation. 4x plus 2x is 6x. That should equal 90. Divide both sides by 6. And x works out to be 15. Now remember, the angles aren't 15, but our x is 15 degrees. So do we have the right answer? Well, we can always do a check. If we know that x is 15, well, this first angle is equal to 4 times 15, because that's what it tells us it is. 4 times 15 is 60 degrees. There's a 60-degree angle. The second angle here is identified as 2x, which we can now say 2 times x is 15. 2 times 15 is 30. 60 degrees plus the 30 degrees together, two adjacent angles, total 90, which they should because they're a complementary situation. So you need to identify the relation that occurs and then write an equation for it. Pause the video, give these two a try on the next page. See what you can come up with, and then we'll talk together. All right, hopefully you gave it a try. This one says create an equation to represent the situation, then calculate the size of wxz after we solve for x. So we know that we have an angle here that's 145, and we have a second angle that's identified as a 3x plus 8. What relation did you hopefully see there? Well, hopefully you saw that right off the bat, that's straight line. I mentioned in the last video, this straight line idea is one I just find students miss a lot. Look for a straight line because together, two angles are supplementary when they total 180 degrees, the straight line. So in this case, we know 145 degrees plus 3x plus 8, the two angles, 145 plus 3x plus 8, has to total the 180 degrees straight angle. Now we can do the algebra. Combine like terms, 153 plus 3x equals 180. Subtract 153 from both sides. 3x works, so it's a 180. Subtract 153, that ends up being 27. Divide both sides by 3, and x works out to be 9. So at this point, we haven't solved the two angles. What we now know is that in the 3x plus 8, we're hoping that x is 9. Let's do a quick check. 3 times 9 plus 8, 27 plus 8. What does that give us? That gives us an angle of 35 degrees. Well, we think the two angles that are adjacent should make up that straight angle. 145 plus 35, there's 180 degrees. The two angles together total 180 when x is 9. So it works out. Now, the next example, if you took a look at it, you noticed, wow, there really isn't a relation here. There's nothing from the angle relations we talked about, but it gives us a whole bunch of information that we need to carefully transfer to our diagram. First piece, angle EFG. There it is there. It says that that is x plus 17 degrees. The next one says angle EFH. E to F to H. That whole big angle we know is 80 degrees. And the last piece, GFH, it says is 2x plus 6. Well, there's no supplementary, complementary, or anything in this case. But what do we know? Well, hopefully, because it tells us the big angle is 80, well, it's made up of the two smaller ones. So we can take the first angle, x plus 17, add it to the second angle, 2x plus 6, and that should total the 80 degrees. Angle 1 plus angle 2 should be 80 degrees. And now we can solve. Combine like terms, x's, constants, non-x's. 1x plus 2x is 3x. 17 plus 6 is 23. And that should total 80 degrees. Solve for x. Subtract 23. 3x equals, when you take away 23, 57. Divide by 3 on both sides. And x works out to be 19. But again, x equal to 19 isn't the size of each angle. We know that that first angle, EFG, was x plus 17. So that angle, x, which is 19 now plus 17, that's a 36-degree angle. The second angle was identified as 2x plus 6. So I now know or think that x is 19. So 2 times 19 plus 6, 2 times 19 is 38. 38 plus 6 is 44 degrees. The two angles together 36 plus 44 totals 80 degrees. And that's what the question said it should. So x equal to 19 works out for the situation. Great little worksheet, makes you think and brings together two concepts you need to be familiar with. Introduction of the angle relations, the easy ones, and then a little bit of algebra. Not overly complicated, hopefully. Here's 3 questions. That's the only part of the assignment now for this, but make sure you do it, make sure you understand it. Answers are in the Brightspace folder that says it's the answer key for this. Check out the answers. Look at my work. Hopefully, you could put it all together. The only way to get good at it is to do it. Practice and have fun.